Variance and standard deviation. Now, variance and standard deviations are also measures of dispersion, just like the range. However, the difference is that these are measures of dispersion which use all the data values. Remember, range used only two of the data values, the highest and the lowest, but standard deviation and variance use all the data values. Standard deviation is a positive square root of variance, so they're related with each other. And variance is the square of standard deviation. And variance and standard deviation can never be negative. Example, let us find standard deviation if variance is 81. So as we said, standard deviation is the square root of variance. So be square root of 81, that's 9. Example, let us find variance if standard deviation is 4. So as we said, variance is the square of standard deviation. So it would be 4 squared, which is 16. Variance and standard deviation are 0 if and only if all the values in the data are the same. So for example, the standard deviation of this data, which is 4, 4, 4, will be 0. Variance will also be 0. Lower standard deviation means higher consistency, and higher standard deviation means lower consistency. Example, funds A, B, and C have same means but different standard deviations, namely 6, 8, and 9. Which fund is most consistent? So as we said, to be more consistent, you should have a lower standard deviation. So fund A is most consistent. Example, find the mean, standard deviation, and variance of the following sample. So we will use the TI-30 calculator to use that. I'm going to use multi-view. So let me show you. So that values are 3, 4, 5, and 1. So let's see. So what we do is you will hit the data button and you will hit 3, enter, 4, 5, enter, and 1. Remember the values were 3, 4, 5, and 1. You can put them in any order. And then you do second stat. Stat is over the data button, the second function. And we want one variable stat. So we enter there. And we want L1 to be 1. We want data to be in L1, which is what it was. And we want all frequencies to be 1. And calculate. So the SX is the sample standard deviation, X bar is the mean. So mean is 3.25 and standard deviation is 1.708. So SX is the sample standard deviation. So mean 3.25. And standard deviation was 1.708. And the reason why we wanted sample standard deviation was because they were saying the following sample. And variance, as we know, is, so let's say we have to round to 3 decimal places. So in this case, that'd be 1.708. And variance will be the square of the standard deviation. So it would be, let's copy this template. It'd be the square of 1.708. And let's find it out. So when I do 1.708 square, I get 2.917. Okay, so these are the answers here. So now the next example is almost the same, but now they say what would be the mean, standard deviation, and variance of the population data. So in the previous example, we were told that this is a sample data. So we got S6 as the sample standard deviation. And here it's the population data. So the mean will still be the same whether it's sample or population. So mean is 3.25 again. And now let's see where on calculator we have the population standard deviation. So if we scroll down on this screen, so this is SX, which is the sample standard deviation. We go down, we have sigma x. Remember, S was the symbol for sample standard deviation and sigma was the symbol for population standard deviation. So we see population standard deviation is 1.479. So we will record that. 1.479. And now variance will be the square of that. So square of 1.479. And that I find to be 2.187. And again, we are assuming that they ask us to round to 3 decimal places. They can ask us to round to any number of decimal places.